Okay, yesterday we looked at first derivative and second derivative tests. Today we're going to do a short lesson where instead of looking at the analytical portion, which is we take the equation and we identify intervals of increasing, decreasing concavity. Today what we're going to do is we're going to look at the graphs. The first graph is different than all of the rest. This is f of x. The other graphs that we look at are going to be f prime of x. So please take note of that. By looking at this graph, if you were to estimate on the intervals in which this function is increasing, where would you say this function is increasing by looking at the graph? Sure, negative infinity to negative 5, union with negative 2 to infinity. So decreasing from negative 5 to negative 2 then? Everybody okay with that? Where would you say is the local max? Negative 5, positive 2. So that's an actual coordinate, the location of the max. The local min, negative 2, positive 2. Now concavity is really the second derivative test. I did that exact same thing second hour. Exact same thing. All right. Concave up, concave down. Right here, am I holding water or shedding water? Shedding water. So it's concave down here. It's concave up here. Where does it look like it kind of switches from concave down to concave up? Estimate it. Sure, like negative 3, negative 3.5, something like that. So I'll call it negative 3.5. So then it's concave up from negative 3.5 to infinity, and it's concave down from negative infinity to negative 3.5. So, Allie, can you share what kind of clicked for you? Oh, yeah. Yep. The inflection first really helps you kind of see, yes, without a doubt. Okay. All right. So that's a basic example, but those aren't the type of questions that you're going to get asked on the AP exam, nor in your assignment today. Instead of giving you the function, they're going to give you the first derivative. So you got to follow closely here. It's not that bad, but the first time you see it, it's somewhat confusing. We have to really think about the definition of increasing. And the definition of increasing is where f prime of x is greater than 0. Well, I'm not looking at f of x. I'm looking at f prime. So how would you describe where this is greater than 0? You'd say the graph is greater than 0 wherever it is above the x-axis. So again, we're not wondering where f prime of x is increasing. We're wondering where f of x is increasing. And f prime of x tells us that the derivative is positive from negative infinity to negative 3. So it's increasing from negative infinity to negative 3. Because it's above the x-axis, it's positive. Union with? Yep, 5 to infinity. So it's decreasing, and the definition for decreasing, again, is wherever f prime of x is less than 0. Good. So before I go to the inflection and concave up, concave down, I'm going to continue to talk about the first derivative, and I think that that's helpful to look at the local maxes and the local mins. The max happens where f prime of x changes from positive to negative. Do you see where f prime of x changes from positive to negative? Catherine? Negative 3. So that's an x value of negative 3. Notice the difference. Here we were able to actually say that the local max occurred at negative 5, positive 2. We don't know a y value for location. You might say, well, yeah, we do. It's 0. Well, that's the location of the first derivative. We don't know the location of f of x. So all we know is that at x equals negative 3, the derivative changes from positive to negative. The local min occurs where f prime of x changes from negative to positive. That's going to be at 5. Now, concavity and inflection, we do not, yes. That's correct. When you are given f prime of x, you cannot give the coordinate. You can only tell the x location. See that? All right. As we talk about concavity and inflection, we are going to look at the second derivative. Now, we only see the first derivative. What would we do to show the second derivative? A tangent line. So if I had a function, well, just like this one over here, this is f of x, right? If you were to look at f prime of x, you would look at a tangent line, or, which is going to represent the derivative, right? Well, if we want to look at f double prime is the derivative of this. How would we show the derivative of this? We would draw some tangent lines, okay? And so these blue lines right here, oh, that was not very good. I'll try to move that one. There we go. So these blue lines represent the second derivative. And the definition for concave up is f double prime of x is going to be greater than 0. So over what intervals do you say that the second derivative is going to be positive? Right here is this blue line. Does that tell me that the derivative is positive or negative? Negative. Negative. No, it's positive. So where is it going to be positive? From where to where? From 1 to infinity. So it looks like right here is where it changes from a slope that would be negative to a slope that would be positive. In this case, the parabola. Okay, so concave down would be where the second derivative is negative, from negative infinity to positive 1. The inflection point is where the second derivative changes sign from positive to negative or negative to positive, okay, wherever it's equal to 0. Where is the second derivative equal to 0? Where does it change sign? Where does it change from negative to positive? At x equals 1. A little bit different, huh? So let's try, we're going to do this one together, and then you're going to do the last one on your own, and then you'll have the assignment, okay? So let's start with increasing. This is, always make sure that you look at the label. This is f prime of x. If this is f prime of x, I want to identify where f of x is increasing. So I'm going to look for where this is above the x-axis, and what intervals would that be? So decreasing wherever it's below, so I can fill in these gaps here. So it looks like from -5 to -1, union with 3 to 6. Are we all okay there? Again, I like to go then to the local max and local min because I like to use the first derivative test to tell me something about that. So the first derivative test will then tell me that local max, I'm looking for where it changes from. And it looks like here's where it changes from positive to negative, and here's where it changes from positive to negative. So that'll be x equals and 3. Local min is where it changes from negative to positive. So can you guys see that by the time, you get ready for the AP test and you show up, that if you're looking for, say, increasing, that you would maybe be tempted to say from -3 to +1, when really you're looking at f prime of x. And so the AP exam, there's a lot of parts of it that really aren't that bad. It's just understanding what you're looking at and remembering the types of problems we covered. This is classic AP exam type problem right here. Okay. So they wouldn't ask all these pieces. They would just say, intervals which it's increasing, or local max, or something like that. Okay, so we'll go to then concavity. So concavity is going to be the second derivative. And so the way I represent the derivative of the derivative is I'm going to draw that tangent line. So positive or negative. So I'm going to be concave down from negative infinity to what? Negative 3 union with 1 to 4. And I'm going to be concave up from negative 3 to 1 union with 4 to infinity. So inflection is wherever the second derivative changes sign. It looks like it's going to be right here, and right here. So those are x values of. You try the last one on your own. Anybody see an issue? Well, thank you. That's so nice. Compliments flying. All right. I'll leave that up there. I'm going to quick turn to your assignment, and you can go back and check this if you want. Your assignment, nice and short. Please just add this to yesterday's assignment. Okay. And we'll venture into something new tomorrow. I sure can. I sure can.